all I'm doing is plugging into values, okay, and going from one to the next. Whatever the base is of my exponential function, whatever is being taken to a power, the 2 on number 2, the 3 on number 3, that's what keeps getting multiplied to find my next value, as long as I'm counting by 1 with my x value on the left side. Now, if I'm going up by 2 or if I'm going up by 4, if it varies, then you've got to pay attention to what's happening. Okay, but if my x value is just counting by 1 every single time, I'm just going to multiply by whatever that base is. Once I have kind of an idea of where my starting point is, I'm just going to multiply by 3. So then whenever we get into exponential growth and exponential decay, yesterday at the very end, whenever we did the exploration, we had when x was negative and whenever it was in the exponent spot. Everything we dealt with yesterday was 2 to the x power, and then we manipulated it there, either with an h value, a k, or an a value, depending on if it was a scale factor, if it was a vertical stretch or a vertical shrink, if we moved it left or if we moved it right, or if we moved it up or if we moved it down. And then the very last thing dealt with when it was like 2 to the negative x power. Well, like we talked about before, whenever we have a negative power, that's going to flip it or make it the reciprocal of whatever my value is. So whenever we have exponential growth or exponential decay, it's real simple. If your base is bigger than 1, okay, like it says basically right here. If your base is bigger than 1, then it's going to be growth. If it's 1, nothing's going to change. It's going to stay at 1. But if you have a value, it doesn't matter if it's 1.1. Okay, if it is bigger than 1, and it is the base of your exponent, it will be exponential growth. Now, hopefully you understand that the bigger the number, the bigger the base, the more growth it's going to have. If something doubles in size, okay, versus something that's going to triple in size, what's going to get bigger faster? The one that's going to triple, right? Or multiply by 3. If something quadruples in size or gets to the 4th power, is 4 as my base, it's going to get bigger faster. The graph is going to get taller faster is really what's going to happen. Okay? Whenever I have this, I always have an asymptote, okay? This says that the x-axis is the asymptote. I'm going to tell you something a little bit different. Okay? Your k value is your asymptote. I don't like just saying that the x-axis is the asymptote. It's whatever your k value is. Okay, so if we move everything up or down, even if we flip it, okay, even if we make it go in a negative direction, your k value will always be your asymptote of your function. So in this case, we don't have a value like there in yellow. So in this case, it is. Normally, if you don't have a k value, if k is 0, then your asymptote is at 0. Okay, but your asymptote will always be whatever your k value is. I don't care if it's positive or negative. If you're adding or subtracting something at the very end, not in the exponent, but at the very end, that is going to be your asymptote. Then, next easiest point or way to find a value is here on the right, where it says the graph rises from left to right, passing through the points of 0, 1. Now, that's of my parent function. The easiest place to always plot a point is when x is at 0. Okay, that will always be your easiest point as far as to have a reference. So what I want you to do, we'll talk about decay in a second. Okay, so right below where it says, tell whether the function represents exponential growth or exponential decay. All right, A represents growth. I'll go ahead and just tell you that right now, and we'll talk about that in a second. So whenever we solve any of these, so we're just going to look at A, okay, because this is the one that's going to deal with growth. Okay, this is growth. The steps in which we do everything, okay, I'm not telling you have to follow these exact steps, but it's going to be a heck of a lot easier if you do. Okay, because everything we do, we always had certain ones that we had, like the blanks that we had to fill out. There are going to be 4 things that you're going to have to fill out here. The first one, okay, and in no particular order as far as how they'll be listed, is going to be your asymptote. Your asymptote in this case is going to be a y equals, because it's going to be a horizontal line. So if I have y equal to 2 to the x power, do I have anything back here that's getting added or subtracted? What is my k value? 0, right? So then in this case, where is my asymptote? Y equal to 0. So that means what I'm going to do is I'm going to have an imaginary line on my x-axis. Okay, normally what you want to do is just make it like a dashed line. That's just going to tell me where the graph is getting closer and closer to. Okay. For right now, it can't cross over that line. When you get into pre-calc or whenever we get further into it, if we get into rational functions, things can cross over this line. Okay, what it's just telling you, all the asymptote is really just, it's like a magnet that your graph is getting closer and closer to, but the only thing different between this and a magnet of something that's metal is that it'll never touch it. Okay, it'll just keep getting closer and closer to it. Now, in exponential growth and decay, it'll get closer and closer to it in one direction, but in the other direction, like as far as going left and right, it will also get further and further away from it. Okay? So depending on if you have growth or decay, as far as it's similar to like a plane taking off or a plane coming in for a landing. Okay? Or a submarine diving down into the ocean or a submarine coming up to the top of the water. So the first thing we want to do is we want to find the asymptote. Second thing we want to do is find the y-intercept. So we want to see where does this thing cross the y-axis. So if we want to know what the y-intercept is, all that is just a fancy way of saying plug in 0 for x. So if I plug in 0 to my equation, I'm going to have y equals 2 to the 0 power. Well, what is 2 to the 0 power? 1. Now, go over to my graph, put a point at 1. The other two parts, whenever we graph this, are to have my domain and my range. Every single time, if I am dealing with exponential growth, every time, my domain, every day of the week, twice on Sundays, negative infinity to positive infinity. This is one of those that if you don't get it right, I can't help you, because it's going to be the same every single time. So every time we deal with exponential growth, there is not a number that I cannot plug in to my x value. I can always put 2 or 3 or whatever my base is to a power. So there is always a value. The domain of an exponential function will always be negative infinity to positive infinity. The range is a different story. It's not as simple. But what it does do, since we just found we have this imaginary line that's the asymptote that's at 0, and we have a point up here at x, or at, excuse me, on my y-axis that's at 0, 1. That means that the graph has to be on the top side of that line. Your range will always deal with your asymptote and then either above the line or below the line. Since it's above the line, where do you think it's going? Is it going to go to positive infinity or negative infinity? Positive infinity. A lot of this is going to be common sense because since it's above the line, your range is always going to deal with your k. So in this case, it's not going to touch k, so it's going to go from 0 to positive infinity. Notice that it is a parenthesis, not a bracket. Because it'll never touch 0. It'll get closer, it'll get closer and closer and closer to 0, but it will never touch 0. Not right now. Okay, not with an exponential. When we get to rationals later, yes. But in this case, it will never cross 0. It will never touch 0. It's like whenever you have, that little sibling and they, you would pick on them, or your older sibling would have that finger and they would like say, I'm not touching you, I'm not touching you. Right, they're not touching you, but you're really ticking me off. Right? Okay, they may not touch you, but they're getting really, really close. So now as far as my graph, then it just becomes finding a few spots that's going to make this thing easier to graph. What's a good number to plug in, do you think, to find the next point or find another point on my graph? What would be a good number to plug in for x? I already have 0. What would be another one? 1. So if I plug in 1, okay, just so I have a reference, if I have x and if I plug in 1, what is 2 to the first power? It's 2. So I'm going to go over to 1, I'm going to go up to 2, and I'm going to plug in my point. What would be another value? Probably 2. What's 2 squared? 4. So go over to 2, up to 4. Okay. I may be able to get another one in there, I may not. In this case I can. So I could plug in 3 for x, and I could have 2 to the third, and I could get 8. And I could have a spot here at 3, 8. Now, whenever I draw it coming back, all I'm going to do is just basically take my line. I'm going to run it as close as I can to that value, and I'm just going to bend it up. Whoop. And take off. Or I would do everything. If you want to put the domain in every time, that's fine. Okay, negative infinity, positive infinity, go that route. Then I would find the asymptote, then I would find the y-intercept, then I would find the range. Okay, just like any other graphing type problem that we've had before. You get 1 for breathing, you get 1 for every blank, and then you get 1 for the graph. So in this case, this is worth 6 points. Hopefully, okay, the graph doesn't have to be perfect. You need to be in the ballpark. If you've got some point, like we've talked before, if you have some point and your graph looks like this, and it's way up there, probably not going so well. You have 2 different points that we already gave you, okay, or you already found. So the graph at least needs to go through those 2 values, or about where you think they are. In some cases, they're going to be a really, really small number. That's okay. Okay, a really small fraction. Now, if I do the same thing for decay, but decay is a little bit different. What do you notice the difference between the growth function and how it's shaped and the decay function and how it's shaped? They're opposite, right? They're inverses of each other. Okay? Or no, they're not inverses, excuse me. They're flipped over the y-axis. Where in this case, whenever you have a base that is between 0 and 1, what's a fancy way of saying that it's between 0 and 1? It's a fraction less than 1. 1/2, 1/3, 3/4, 2/3, 11/12. If it's less than 1 and it's a fraction, it's going to be exponential decay. It is losing value. Okay? The plane is losing altitude, and it's coming in for a landing. Same way with the submarine, what's going to happen, it's getting closer and closer and closer as it's moving from the left to the right to your asymptote. Growth is going to leave the asymptote. Decay is going to come into it. We still do everything the same way whenever we graph it. It's still going to have the same domain. The range is still going to fit the same type as far as my K value. I'm still going to plug in 0 for my X or my Y intercept. I'm still going to look at K for my asymptote. None of that changes. If it's above my asymptote, it's going to go from the asymptote to positive infinity. If it's below my asymptote, then it's going to come from negative infinity to my asymptote. You do everything the same way as we did here. Maybe. There we go. So I'm still going to find 4 things. I'm still going to find my y-intercept. I'm still going to find my asymptote. I'm still going to find my domain. And I'm still going to find my range. Automatically, domain, negative infinity to positive infinity. Y-intercept. Plug in 0 for X. So whenever I do, I have y equals 1/2 to the 0 power. Anything to the 0 power is what? 1. So I can put a point at 0, 1. What's my asymptote? What's my K value? Do I have anything that I'm adding back on the back end? Nope. So it's just going to be y equal to 0. So just like I did before, I'm going to have an asymptote here. So then, if I have a point above my asymptote, domain is negative infinity to positive infinity, what's my range? It's on the top side of my asymptote, so where's it coming from? Or what's the lowest value? 0 to positive infinity? I'm looking at 5 out of 6 right now just there. And I haven't done really anything that difficult. Now, the one thing I will tell you whenever we have decay is if I plug in a value, if I plug in a value for x, if we know that we have a point at 0, 1, and then you just go with 1, what's 1/2 to the first power? 1, right? So it's down here. You may still look at it and go, okay, something's maybe not right. There's 2. What's 1/2 to the second power? What's 1/2 times 1/2? 1/4. It's starting to come into my asymptote. So if you have to go back, same way, if I go in a negative direction, what's going to happen if I have 1/2 and I have a -1? What's it going to do to my fraction? Isn't it going to flip it to 2/1? So what happens is it's going to take it basically from the backside and it's going to come up like this. It's going to come in for that landing. Just like it did, just basically the opposite of what it did before. Yep.